It's one of the most advanced, most expensive, and honestly, most secretive aircraft ever built. I mean, this is a machine designed with just one thing in mind: to be totally, completely invisible. So today, let's dive into the incredible engineering behind the B-2 stealth bomber.
So here's the central paradox of the B-2, and it is a wild one. You're talking about a heavy, strategic bomber, right? Wingspan of 172 feet, weighs over 160,000 pounds empty. And yet, to an enemy radar system, it looks no bigger than a bird. It's basically a ghost in the machine of modern air defense.
So yeah, that's the big question, right? How is that even possible? How do you take this giant piece of machinery, pack it with 40,000 pounds of munitions, and just make it disappear from the best detection systems on the planet? Well, it all comes down to solving a whole series of massive engineering problems.
Okay, so the first and biggest hurdle you have to clear is radar. The entire B-2 program was basically built around this one challenge: how to make this bomber invisible to those electronic eyes that are always watching the skies.
You know, radar is basically a game of high-tech catch. A station throws out a radio wave, and if that wave hits something flat, like say the tail fin or the side of a normal plane, it bounces right back to where it came from. Boom, the plane's presence is announced. And most planes are just covered in these perfect little radar mirrors.
So the B-2's designers took a pretty radical approach. They just got rid of all those problem surfaces. Gone. No fuselage, no tail. What you're left with is this flying wing design, which is basically one continuous curve. So now when our radar wave hits it, it doesn't bounce back home. Nope, it defricts away, just scattering out into the atmosphere, totally lost.
Now, the shape is just the first line of defense. The second is the B-2's skin. It's coated in this top-secret stuff called radar absorbent material, or RAM for short. And it does exactly what it sounds like. It literally soaks up radar energy, turns it into a tiny bit of heat, and stops it from reflecting. It's like a stealthy sponge for radio waves.
Okay, so here's the thing. In solving that huge radar problem, the engineers created a brand new one, a massive aerodynamic one. See, without a tail and stabilizers to keep it flying straight, a flying wing is just naturally unstable. It wants to wobble and pitch all over the place. To put it bluntly, it just kind of wants to fall out of the sky.
So, how do you fix that? Well, the solution wasn't around back in the 1940s when they first tried making flying wings, but by the 1980s, it was computers. See, in a normal plane, the pilot's stick is physically linked to the flaps, but in the B-2, the pilot's commands go to a super sophisticated fly-by-wire system. A central computer makes thousands of tiny adjustments every single second to keep the plane stable. So really, the pilot doesn't fly the B-2. They just tell the computer where they want to go, and the computer flies the plane for them.
And here's how that actually works. To turn, the computer uses these split rudders out on the wingtips. They pop open and create a little drag on one side. To go up and down or roll, it uses a whole series of flaps called elevons. And the key is everything is being managed in real time by that super fast computer, which turns this totally unstable design into something perfectly flyable.
Okay, so we've solved the radar problem. The B-2 is a ghost. But radar isn't the only way to spot an airplane, right? You've got 4 massive jet engines powering this thing, and they put out a ton of heat. That basically paints a giant "I'm right here" sign for heat-seeking missiles and infrared sensors. So solving that problem was the next big challenge.
And the solutions they came up with were just as clever. First off, those 4 huge engines are buried deep inside the wing, which helps hide their heat and their sound. Then you've got the air intakes. They're S-shaped. This is a double win. It hides the spinning fan blades from radar, and it helps cool the air down. But here's the most important part. The hot exhaust doesn't shoot out the back like on a normal jet. It gets vented out through ports on top of the wing where it's mixed with cool air. This drops its heat signature way, way down, making it almost invisible to anyone or anything looking up from the ground.
So the B-2 can hide from radar, it can hide from heat sensors, but a stealth bomber isn't much good if it can't actually get to the target, right? And for the B-2, getting to the target means being able to fly pretty much anywhere on the planet from its home base in Missouri, all while staying a complete ghost.
Now, the B-2 has an incredible range on its own, but for those really long-haul, globe-spanning missions, it's got to refuel in midair. And this is like a high-stakes ballet in the sky. A tanker plane flies above, and this special fuel port on the B-2's back just spins open. It takes on tens of thousands of pounds of fuel, and then, this is the magic part, the port swivels shut and just disappears, blending perfectly back into the wing, leaving a totally smooth surface.
And here's why that seamless design is so critical. This quote really says it all. Just having that small port open, even for just a few minutes, makes the B-2's radar signature triple. It just goes to show you, every single little piece of this aircraft is designed with one goal: maintain that tiny pigeon-sized signature.
So, okay, we've seen all this incredible technology, but what's the true price of stealth? And I'm not just talking about money here. It's about a constant, absolutely monumental human effort.
All right, let's start with the money, the pure sticker shock. Back in 1998 dollars, a single B-2 bomber cost over $1.1 billion. That makes it by far the most expensive aircraft ever built, period.
And believe me, the cost doesn't stop when you buy it. For every single hour a B-2 is flying, it needs a staggering 50 to 100 hours of maintenance back on the ground. To put that in perspective, your average commercial airliner is about 12 hours. A huge chunk of that time is spent on the constant, delicate upkeep of those stealth coatings. The very materials that make it invisible are also super fragile.
And because of that insane cost to build and maintain, only 21 B-2s were ever made. That's it. It's an incredibly rare and valuable piece of technology, and each one needs its own dedicated team of specialists just to keep it flying.
And this quote from a low observable technician that's a stealth specialist, it really drives home the reality of the situation. He says the aircraft comes back with at least a few maintenance needs after every flight. Think about that. There's no such thing as a simple trip for a B-2. Every single mission, no matter how routine, means hours and hours of meticulous inspection and repair.
And here's the bottom line. It's not just about keeping the plane in the air, it's about keeping it invisible. As Staff Sergeant Finn says here, one tiny flaw in their work, one single little defect, and the whole mission could be compromised. The pilots could be put at risk. The human factor, that meticulous, constant work, it's the absolute backbone of this technology.
So, the B-2 first took flight way back in 1989 and officially entered service about 8 years later. It proved its worth time and again in conflicts from Kosovo to Afghanistan, and while it's still a cornerstone of U.S. air power today, its successor, the B-21 Raider, is already in the works, designed to take everything the B-2 taught us and push it even further, hopefully with a much lower price tag.
So when you really look at it, the B-2 Spirit is this monument to engineering. It's a machine that took on the problems of radar, heat, and stability and just solved them. It totally redefined what we thought was possible. But, detection systems are always getting better. And that leaves us with a pretty fascinating question for the future. What is the next great problem that engineers will have to solve to achieve true invisibility?